The adiabatic cooling effect, what is it? Adiabatic cooling is a natural phenomenon caused by a phase transition of a substance from one physical condition to another. Water needs energy in order to change from solid to liquid condition or from liquid to gaseous state. If frozen water is heated from -15 degrees Celsius, the temperature rises continuously until the melting point is reached. Once the melting point has been reached, the energy of the particles starts to change. The substance's physical condition now also changes. During the transfer to the liquid state, its temperature remains constant. The energy needed by water to pass a phase transition is referred to as the specific melting energy. This energy is different for every substance. If additional energy is now added, the water temperature increases continuously until it reaches 100 degrees Celsius. When the specific boiling point is reached, a substance starts to change its physical condition again. During its full transfer to a gaseous state, the temperature does not change. The energy needed by water to pass the next phase change is referred to as the specific boiling energy. Once a substance has been completely transformed into a gaseous state, its temperature starts to rise again in proportion to the additionally added energy. However, the phase change need not necessarily take place at boiling or melting point. Water may evaporate at very much lower temperatures by using energy from its environment for its phase change. The amount of energy required to execute a phase change is also widely used in nature to produce a cooling effect. For example, when people transpire, sweat is exuded from their pores. The sweat evaporates on the surface of the skin. The thermal energy needed for the evaporation process is taken from the body. The body therefore achieves adiabatic cooling through evaporation. In HVAC systems, adiabatic cooling can be used as a cost-effective alternative to conventional mechanical cooling. The exhaust airflow from a room can be cooled by means of an evaporative cooler. A cross-flow heat exchanger is used to cool the air sucked in from outside. Using an evaporative cooler allows to do without a cooling coil, or at least to reduce its size, and therefore its power consumption significantly. If correctly calculated, this leads to significant savings in operating costs.